This is lesson number 52 in our unit on systems of linear equations. In the past, we've been using the substitution method to solve for each variable in a system of linear equations. Today we're going to learn a new method called the elimination method. And by the end of this lesson, we'll be able to understand how to solve systems using addition in the elimination method. So here we have two equations, both part of a system. One is 4x plus 6y equals 32, and the other is 3x minus 6y equals 3. So if you take a look in the right-hand corner here, I have some steps for us. The first step is to write the system, actually this should say the equations, write the equations so that like terms with the opposite coefficients are lined up. So remember, like terms have the same variable, so we want to take a look at our x variables. Do the x variables in these equations have the same coefficients but with different signs? Well, one has a 4, one has a 3, so obviously they are not the same. Let's take a look at the y's. Do they have the same number in front? Absolutely. They both have 6's. And they both have opposite signs, which is super great for us because that means we can easily eliminate the variable. So in order to eliminate the variable, if you look at step 2 over here, I'm going to add the equations. So if I add them, we know that 4x plus 3, so I'm adding vertically, like as if we were adding numbers. 4x's plus 3x's is 7x's. 6y plus negative 6y, well, those go away. Equals, what's 32 plus 3? Well, it's 35. And now look, I'm left with one variable. I divide by 7 to get my x by itself, and I get x equals 5. And now I proceed the same way I did when we did substitution. Now that I have a variable, I pick an equation for, instead of x, I'm going to put my 5 plus 6y equals 32. 20 plus 6y equals 32. When I subtract 20 from both sides, I'll get 6y equals 12 and y equals 2. So my coordinate, or my solution, is 5, 2. So remember, we add the equations in order to eliminate a variable when a variable has coefficients with opposite signs that are the same. Here is my second example. So I have 2x plus 5y equals 6 and 9y plus 2x equals 22. So again, step 1 is to write the system so like terms with the same coefficients are lined up. So if you take a look, I know that my 2x here and my 2x there are the same, so I want to write the system so that they're lined up. 2x plus 5y equals 6. And I'm just going to change the order here. I'm not going to do anything with them. 2x plus 9y equals 22. Okay. Well, now, remember in the last example, the terms with the same coefficient had opposite signs. One was positive and one was negative. Well, here, they're both positive. The 2x and the 2x are both positive. So I'm going to pick one equation. Maybe I'll just pick the top one because I feel like it. And I'm going to multiply it, everything in the equation, by -1. So we're rewriting. If I multiply -1 times, -1 times 2x, I'm going to get -2x. -1 times positive 5y is -5y. And -1 times 6 is -6. Now I rewrite my second equation as it was, 2x plus 9y equals 22. And now I'm back to where I was in the first example. I just add them. Well, -2x plus 2x goes away. -5y plus 9y is 4y. And 22, take away 6. You really just do 22 minus 6. This is 12, 1 is 16. And we divide by 4, so we get y equals 4. And now I just substitute into a new equation. 2x plus 5 times 4 equals 6. 2x plus 20 equals 6. I'm going to come up here. We get 2x equals negative 14. So x equals negative 7. And our coordinates, let me just erase this guy here. So our coordinate, or our solution, is just negative 7, 4. And that is how we use elimination to solve a system of equations.